Welcome to Study Loop.
Let's evaluate the integral. First thing we should do is to see if this denominator will factor. We see that in the bottom. We can pull out x squared, and you're left over with x squared plus 6. So for the first term in the denominator, we see that this is a repeated linear factor, x times x. Now for this other quadratic, x squared plus 6, we'd like to see if that factors. So to do so, we check the discriminant, which is b squared minus 4ac. Here, b is the coefficient in front of the x. There's no x here, so that's a 0. Minus 4 times 1 in front of the x squared, and then times c, which is 6. And that is definitely less than 0. This tells us that the denominator, x squared plus 6 term, will not factor. So for the first term, x squared, we can use what the book calls case 2, repeated linear factor. And then for the last term, x squared plus 6, we'll use what the book calls case 3, cx plus d over x squared plus 6. Now let's take this equation up here and multiply both sides by that denominator on the left. When we do so, we should get x cubed 6x minus 2. Now on the right hand side, we have a x squared plus 6, b, that's times x squared plus 6, and then cx plus d, and that gets multiplied by x squared. Let's just go ahead and expand this right hand side. Ax cubed 6ax, bx squared 6b, cx cubed dx squared. And then now let's combine like terms. We see that we can plot a x cubed a plus c, x squared b plus d plus x, and that's just 6a next to the x. And then the constant term is just that 6b. So we'll have 4 equations here. We see that a plus c must equal 1, because those are the coefficients in front of the x cubed terms. On the left, we see that there's no x there, no x squared term. That means that b plus d must be 0. In front of the x on the left, we see a 6. So on the right, that must mean 6a equals 6. And finally, the constant term on the left is minus 2. On the right, it's 6b. Those must be equal. Let's write and solve this 4x4 system on the next page. Our equations: a plus c is 1, b plus d is 0, 6a equals 6, 6b minus 2. Solve that for b. Solve this equation for a. And then we can go ahead and plug in our a and b values to solve for c and d. C is 1 minus a is 1, so we just get 0 for c. B equals negative d, or let me write it as d equals negative b equals 1/3. Now let's plug in these values for a, b, c, and d into our partial fraction decomposition. And we have 1 over x minus 1/3 x squared. That was for b. And then c was 0, and then d was positive 1/3. Now we could go ahead and write this as 3 separate integrals. You see the second integral there. You could use the power rule for that one. And then the last integral, pull out the 1/3. And technically, I should be putting the dx's here. Dx, dx. Now, for this term, we know that's just natural log absolute value x. Here, this will be negative 1/3 times negative 1 over x after using the power rule. So that's just 1 over 3x. And then for this last integral, you might remember this from my table. If not, we'll do a trig sub. Let's come over here for that. X equals √6 tan theta. Then dx equals √6 secant squared theta d theta. So we have 1/3 integral dx. And then on the bottom, x squared. So that's 6 tan squared theta. And then plus 6. Let me factor out that 6. And then we know that tan squared plus tan squared plus 1 is secant squared. So these terms are equal. And we could go ahead and cross those off. We get √6 over 18. That's the 3 times the 6 in the bottom. Integral d theta. So that's √6 over 18 of theta. And then we can solve for theta by taking our trig sub over here and just solving that for theta. So we have tan theta equals x over the radical 6. So theta equals tan inverse of x over radical 6. So let's write that over here. Radical 6 over 18, and then arctan x over radical 6. And that's the third integral. So the last thing to do is write the sum of these three terms. And so let's go to the next page to do that. So we had the first integral, natural log absolute value. Second integral, 1 over 3x. And then for the last integral, which required the trig sub, √6 over 18. And then we had arctan x over radical 6. And then don't forget our constant c of integration, and that's our final answer.